This pattern numerical is very important for entrance examination. This model numerical is very important for the objective pattern exams when they give percentage purity of the substances. When they are not giving percentage purity, the numerical is very easy. When they give some percentage purity, definitely it involves lot of calculation. And the advantage here is that given the equation, and what we need to do, the amount of 80% pure iron that could be produced from 120 grams of 90% pure ferric oxide, and the equation is given like this. So now whenever 120 grams of 90% pure Fe2O3 is utilized according to this particular equation, how much quantity of iron is produced which is 80% pure? So first, as both the compounds are not 100% pure, we need to do that calculation separately. First we need to find out in this 120 grams of 90% pure Fe2O3, how much quantity of pure Fe2O3 is present. First let us do that calculation. So now I am saying the meaning of 90% pure Fe2O3. It means when we take 100 grams of the impure sample, it contains 90 grams of pure Fe2O3, and in this case it is given 120 grams of the sample, and that contains how much quantity of Fe2O3. Remember, when they are not mentioning the percentage, it means it is 100% pure, even though they are not mentioning it as pure compound. And as they had mentioned some percentage, that itself indicates that the given compound is an impure compound. So now it becomes 120 by 100 into 90. So for this one, let me take the value as simply 12 into 9 grams of pure Fe2O3. Don't multiply it further so that the calculation becomes easy in further steps. So this is the amount of pure Fe2O3 present with us. Now when we have this much quantity of Fe2O3, we need to first find out what is the amount of pure iron formed according to this particular equation. Then only we can think about calculation of the amount of 80% pure iron. So in the second step, we need to find out the amount of pure iron formed according to this particular equation. As you know, the atomic mass of iron is 56. So when you calculate the molecular mass for the entire substance Fe2O3, it becomes 160. So from equation, when 2 into 160 grams of pure Fe2O3 is involved, the amount of pure iron formed is 4 into 56 grams. Remember, we get it from the equation, or whatever we are using in the equation, there is always for 100% pure substances. Now in this numerical, we got 12 into 9 grams of pure Fe2O3. So when this much amount of substance is involved, how much quantity of pure iron is formed? On solving this, we will be getting the value as equal to 75.6 grams of pure iron. Remember one thing, we are not calculating the amount of pure iron formed in this particular process. We need to calculate the amount of 80% pure iron. So what's the meaning of 80% pure iron? It is an impure sample. So when we take 100 grams of impure sample, it should contain 80 grams of pure iron. That's the meaning of 80% pure iron. So now in this we got 75.6 grams of pure iron. When this is the amount of pure iron to be formed, so what is the amount of impure sample? We can get it. So it is 75.6 by 80 into 100, and that value is equal to 94.5 grams. So our answer is option C. Let me give this approach again. The question is given like this: the amount of pure iron that could be produced from 120 grams of pure Fe2O3. Our answer is only based on this particular step, because 2 into 160 grams give 4 into 56 grams of Fe. So this much quantity gives how much? Or 120 grams gives how much? But here the starting compound given is not a pure compound. So first we need to find out what is the amount of pure Fe2O3 present in the given substance. That's what we had calculated here. Then once we get the amount of pure Fe2O3 present with us, From that one, we can calculate the amount of pure iron formed according to this particular equation. And that calculation we have done it here. The final answer we don't require in terms of pure iron. We require in terms of impure sample, which contains 80% pure iron. So this is the final calculation. I think it's clear now.